As we all know that SpaceX and its founder Elon Musk are always looking and working for innovation and evolution. The difference between SpaceX and NASA is that SpaceX is a private company owned by Elon Musk, an entrepreneur, whereas NASA is a government and funded organization. SpaceX, being a private company, is going beyond and above every other company. It is no doubt an ambitious company and technology enthusiastic. Hello everyone, welcome back to my YouTube channel. In today's video we are going to have a look at SpaceX's biggest Starship evolution. But before we start, make sure to subscribe to this YouTube channel and press the bell icon so you'll be notified whenever I upload a new video. Okay, so let's begin. Upper stage of Starship. The top tier of the Starship is said to act as the second tier to achieve orbital velocity for Earth launches intended for use in space as long-orbit spacecrafts, as well as the SSTO for launches from Mars, the Moon, and possibly other planets or moons. This is different from most previous launch and spacecraft projects. The spacecraft is slated to re-enter Earth's atmosphere at orbital velocity and land vertically, with the project's goal of enabling rapid reuse without extensive upgrades. If Starship were used to launch a space orbit to Mars, operating the entire expedition system would necessarily involve producing fuel on the Martian surface, according to Musk. This is necessary for the return journey and for the reuse of spacecraft to keep costs as low as possible. Lunar destination, moon flights, orbits, and landings will be possible without lunar fuel depots as long as the spacecraft is loaded into highly elliptical orbits before lunar transit begins. Some lunar flights will be possible without orbital loading, as the mission profile of the Dear Moon project shows. What are the general characteristics of Starship? As of September 2019, the Starship's upper stage is estimated to be 9 meters in diameter, 50 meters high, which could become a fully usable spacecraft with 120 tons of dry matter. 130 short tons or less, powered by 6 Raptor engines. Starship is designed with the possibility of re-entry into the Earth's atmosphere and retro-propulsive landing at certain landing sites. Landing reliability is predicted by SpaceX to eventually reach airline level safety due to engine flight capability. The spacecraft is also designed for automatic rendezvous and docking, as well as transport of propellant into orbit between spacecrafts. The Starship is also set to reach other planets and moons in the solar system after being loaded into orbit. While retro-propulsion is intended to serve as a maneuver for the final landing on Earth, Moon, or Mars, 99.9% of the energy dissipation upon entering Earth must be carried away aerodynamically, and on Mars, 99% aerodynamically even in the much thinner Martian atmosphere, where a body valve is used to control altitude during descent and to optimize trajectory and energy dissipation during descent. As predicted in the 2017 design presentation, the Starship is said to have a print volume of approximately 825 cubic meters, which can be configured for up to 40 cabins, large common areas, central storage space, and kitchen and sun shelter for the Mars mission. Let's have a look at Starship propulsion technique and strategy. The methane-oxygen Raptor engine will be Starship's primary propulsion system. Starship will use 3 sea-level optimized Raptor engines and 3 vacuum-optimized Raptor engines. Motors at sea level are identical to super heavy motor amplifiers. Space transport is expected to use a vacuum-optimized version of the Raptor engine to optimize specific momentum to about 380 seconds. The Starship's total thrust will be approximately 14 Mn. The Starship will use a hot gas response control propulsion system with methane gas to control ratios, including maneuvers to then tilt from belly flop to stern before landing and for stability during landing in high winds of up to 60 km/h. Early prototypes used a cold nitrogen gas engine, which was significantly less mass efficient but was suitable to support early test flight tests. Variants. It is planned to build the spacecraft in at least the following operating variants. Crew spaceships, a large long-range spacecraft that can carry passengers or cargo to interplanetary destinations, low Earth orbit or Earth-to-Earth space flights. Surface cargo Starship, a vehicle that can transport large payloads to the surface of other celestial bodies. NASA has signed a contract with this version of Starship as part of the CLPS program to land elements on the lunar surface. Orbital cargo ship, a vehicle capable of transporting a spacecraft and putting it into orbit, or handling spacecraft and space debris to return to Earth or enter another orbit. In the March 2020 Owner's Manual, this is indicated by a large cargo bay door that opens into space to facilitate the delivery and collection of cargo. Self-propelled tanker. Self-propelled tanker is to assist in orbital refueling. Tankers will make it possible to launch heavy spacecraft into interplanetary space because of refueled spacecraft can use its tanks twice, first to reach LEO and then out of Earth orbit. The tanker variant, which is also required for high-performance lunar flights, will not arrive until later. The initial transfer of fuel into space will be from one standard spacecraft to another. Moon services to orbit. Starship variant without air brakes or thermal protection required for operation in the atmosphere. In addition, the spacecraft will be equipped with dock openings in the bow, additional landing gear, mounted much higher to reduce dust clouds upon landing, and white paint as opposed to the bare armor planned for the regular spacecraft. In April 2021, NASA selected the Starship HLS manned landing option for the Artemis program and signed a contract for 2 operational missions to the moon, the second to land humans on the moon in 2024. Starship's design is supposed to be flexible. For example, a possible modification of the base spacecraft would only have a consumable 3-engine spacecraft without fairings, tail fins, or landing legs to optimize its mass ratio for interplanetary exploration with robotic probes. Materials and construction of Starship. Starship has stainless steel construction and tank construction. Its strength-to-mass ratio should be comparable to or better than SpaceX's previous carbon fiber composite designs, within the expected temperature range from low cryogenic fuel temperatures to high atmospheric return temperatures. Some parts of the craft will be built with stainless steel alloy that has undergone a type of cryogenic treatment, in which metal is cold formed and worked to produce a cryogenic treated steel, drastically lighter and more wear resistant than traditional hot rolled steel. The spacecraft will also have a thermal protection system against harsh conditions upon re-entry into the atmosphere. This includes the hexagonal ceramic tiles used on the windward side of Starship. Previous designs include a double stainless steel shell with active coolant flowing between the 2 layers, or with multiple areas containing a number of additional small pores that allow transpiration cooling. Starship Human Landing System. The modified Starship vehicle known as the Starship HLS was selected by NASA for use in a long-range manned landing on the moon as part of NASA's Artemis program in April 2021. This was followed by a 3-team competition starting in April 2020 where NASA wants to encourage commercial companies to develop artificial moon landing systems. The Starship HLS variant is said to live on and around the moon. Therefore, heat shields and air brakes, an integral part of the ship's basic construction, are not included in the Starship HLS as the vehicle will not return to Earth. The Starship HLS is also equipped with a series of mid-body boosts not found in the basic Starship design for use during the final 10 meters of the final lunar descent and final moon landing. The same thrusters are used to lift the lunar surface and are intended to avoid problems with cloud impact on lunar regolith. A large solar array is attached to the circumference of the outer shell to generate energy. Once the Starship HLS reaches Earth orbit, it will be loaded onto the Starship's tanker before heading to the moon. For the Artemis mission, the Orion spacecraft is said to have put the NASA crew into lunar orbit, where they would exit and land on Starship HLS. After lunar operations on the surface, Starship HLS will rise from the lunar surface and meet Orion, who will transport the crew back to Earth. Elon Musk stated the Starship HLS will be able to have at least 100 tons and possibly close to 200 tons payload on the lunar surface. The Starship vehicle design has been criticized for not adequately protecting astronauts from ionizing radiation during interplanetary missions. Musk said he thought the transit time to Mars was too short for a Mars mission and said, "This is no big deal." The increased lifetime cancer risk from doses received during a multi-year mission to Mars is estimated at 5% of the total cancer risk, achieved by simple protective measures. In response to this criticism, Musk's 2017 revision contained solar storm protection. Critics have also attacked Starship's testing campaign at SpaceX South Texas launch pad. Debris from the blast had moved more than 8 kilometers in the wind, leading locals to say that they were damaging the surrounding ecosystem. Environmental activists have accused SpaceX of not complying with the conditions set out in their original environmental impact statement and have urged environmental protection agencies to request an updated EIS. So viewers, this was all about today's video. Thanks for watching this video. I hope you liked this video, and if you liked it, then do give it a big thumbs up. Also, the comment section is widely open, only to get your thoughts on this topic. See you in the next video, signing off.